Hello girls, welcome to our lesson on projectile motion. This, like force summation, is also revision from year 11 work. Turn to page 77 in your workbooks. Okay, a projectile, it's a body that moves through the air. It could be a person doing long jump, diving, gymnastics. Could be a discus, a pole vault, a javelin, a tennis ball. It's just the object or the person that moves through the air. And the trajectory is the path that the projectile actually takes. So here we've got it usually goes in a curve. Oops, where's my... I'll get it red, I think. And that's the path it takes. That is the trajectory, and the projectile, that's the ball, the person, or anything like that. So here we are, trajectory is the path, and projectile is a body that moves. Right? Any object that's released into the air becomes a projectile. All projectiles are affected by factors that determine how far and how high they will go up. It depends, we've got control over some of that, and other things you don't have control over, such as gravity and air resistance. You can't control that. But you can control three factors, which we're going to look at today. Speed of release. Okay, so we've got speed of release, height of release, and angle of release. Those are things that we can change. We can't change gravity, and we can't change air resistance. Although air resistance does change because it depends on the wind, the weather, and air resistance is also influenced by the object or the body that you are throwing. The first factor we're going to look at, which we have got control over, is the speed of release or velocity of release. So the greater the speed of release, the more distance covered, or even the higher the object will travel, depending on the angle you throw it at, of course. A projectile's speed of release is mostly determined by muscles, force, and leverage a body possesses. So it's your maximum force, summation created, and also the longer the lever, the greater the speed at the end of the lever. So if you've got a long lever, you can also create greater speed. You know those people down in the park with a ball for their dog, they've got that long stick with a ball on the end. It's so that they can throw the ball further and make the dogs run further, so they can just sit around and watch the dog run. So that's a long lever that they're using to throw the ball, and you all know how much further you can throw the ball with one of those, I guess. So speed of release is a transfer of momentum. Okay, so speed of release is divided into two components. There's the initial vertical velocity, and that's what we can see here. I better get one that you can see. There we are. That's the vertical velocity. Oh, where am I? Whoa, he doesn't want to write. That's the vertical velocity there. It's the upward motion. And here we've got the initial horizontal velocity. Right, that as shown in your books as well. The flight direction the ball takes off the bat will determine how the ball will fly. So it depends how much vertical velocity there is and how much horizontal velocity there is, how the ball's going to fly. So in the first question, which is higher, the initial vertical velocity or the initial horizontal velocity? And what is the likely outcome? I think you can see it better in my diagram on the previous page. I'll see if I can pop that in here for you too. Okay, here we are. We've got that picture again. So you can see the bat, at the angle of the bat and the speed of release, there's a initial vertical velocity and vertical speed, and there's a horizontal speed, and it's the combination of them both. So the direction the ball is travelling indicates initial vertical velocity is greater. That means it will go upwards, up that way, more so, or maybe that way actually, than downwards. Probably an easy ball to catch, just like our cricket players last night. In many sports, there's a trade-off between initial vertical velocity and initial horizontal velocities in order to get the desired flight path. What would the advantage of having a high initial vertical velocity be, and in which sports would this occur? What sports do you want high vertical velocity? That means you're wanting to go higher rather than like that, rather than like this. That's the horizontal, more horizontal. Whoops, wiping them out. So you will more likely want to have a lot of vertical velocity when you're doing high jump, in gymnastics when you're tumbling, and that type of thing. And the opposite would be for the what would be the advantages of having a high initial horizontal velocity, and in which sports would this occur? So it's things like long jump, discus, javelin. We want the ball or the projectile to travel more like that. So, and that gives the greatest distance. Example is in long jump. How does the athlete ensure a good speed of release for the sport they're doing? Well, as in our previous video about force summation, they have to apply all the principles of force summation to get good speed at the end of the racket, or bat, or hand, or foot, whatever it is, whatever sport you are doing. So that force summation, projectile motion, they really are linked very, very closely. They interrelate. The next factor that we're going to look at is angle of release. The angle of release that a projectile is released from. So the angle of release is taken from the horizontal. So if it's horizontal to the ground, I haven't got much room here to draw, so I'll draw that on the next one for you, next slide for you to show you. The optimum angle of release is 45 degrees for maximum distance. If you're going for best distance, e.g. in throwing a tennis ball, throwing a cricket ball from the outfield, throwing a discus, maybe that might fly a bit flatter than 45. But for maximum distance, we just always say 45 degrees is the best angle. Greater angles than 45 will result in a shorter distance and get greater height and a longer flight time. So an example of things that you want to have greater than 45 degrees will be high jump. It's important that that is that's greater than 45 degrees. A standing back somersault's another thing. You want plenty of time in the air when you do a standing back somersault, and you're going up at probably 90 to 80 degrees with that one. Lower angles than 45 degrees will result in shorter distances, lower heights, and shorter flight times. An example of this is a tennis serve, where you're wanting the ball to travel in a downwards direction, a downward attacking direction, so it lands in the opposite serving box and it's in, and it will be difficult for the opposition to return. A volleyball spike and a volleyball serve are other skills that you will probably be using that have angles less than 45 degrees, because they're all downward movements. I've got some pictures here of people throwing balls. I'm going to try and show you how you identify the angle of release. So the ground is there, and we take it at a horizontal there. That's horizontal to the ground. And then this girl, she's doing looks like a push pass and a pass and netball or something. And this is her angle of release. It's like that. All right, so that is the angle there that we're looking at. I don't know, that's probably just a bit less than 45 degrees, that one, because you can put the upright on and you girls know that that's 45 degrees. So that looks like, to me, about a 30-degree pass, angle of release. Here we are, we've got someone, I don't know what he's doing, something, throwing the ball, shooting maybe, catching a ball. Anyway, we'll pretend that he's throwing it. So that's the angle of his pass. We put the horizontal in, horizontal straight to the ground, parallel to the ground. See, it's parallel. Those are your little maths signs, aren't they? And this is the angle we're looking at. And that looks like about 45 degrees to me. Here's the 90 degrees. And that makes it about 45 degrees. This one here, it's probably about 30 degrees. Can you understand that? Here we are. I've found one that's been online that was already done. And here's our guy standing on the ground. I'll choose a different colour. Here he is standing on the ground, sort of. There's the horizontal to the ground. And I think these angles here they've calculated. I'm not sure where they've calculated them from. Here, I think. So we'll go up here. And that's 70 degrees there, that big one. 70 degrees, 50 degrees, and 30 degrees. Can you see that now, how they work that out? I think that looks about right. So the angle is calculated from a parallel to the ground. For different activities, you require different angles of release. So we've got the 90 degrees at the top and going right down to minus 90 degrees, so we've got 90 degrees going right down to less than 90, minus 90, the negative of 90 degrees. So this here is exactly on the horizontal, 0 degrees. I'll put that in like that. Here we are, we've got Valerie Adams, it looks like, doing the shot put, about 45 degrees. So it's 45 degrees. 90 degrees is straight up, isn't it? This is the 0 degrees. And then here we've got activities that use gravity and horizontal distance. So we've got gravity, taking the ball down in volleyball. And gravity, that's the block there. I think that's a volleyball block. And then finally, activities that use gravity and vertical height. So as we've seen, different sports have different angles of release depending on the objective of the sport that you're playing and what you want the projectile to do. So what would the angle of release of a shot put be, and explain why? And as we've seen from the diagrams, the release of a shot put would be around about 40 to 45 degrees, as this would give us the best distance and time in the air. And what would happen if the angle of release was too high? In other words, it wasn't 45 degrees that we were throwing the ball at, it was it was too high, like a flight path like this, or I'll get rid of that off there, like that, well, you wouldn't get it, it wouldn't fly as fast, as far. 45 degrees is going to fly like this, nice and long, hopefully. So if it's too high, you won't get a good flight path. And if the angle was too low, it wouldn't get enough time in the air. It would just go boom, so you wouldn't win it. Right, using that knowledge that we've been talking about angles of release, I want you to answer question 4 on your own. The first one, so you've got to rank them all. You've got triple jump there, and you rank to the, whoops, sorry, knocking something around there. You're to list them. The lowest angle of release, that's one that's low like this, perhaps going, this is a low angle of release, and this is a high angle of release. So, when do you want to have a low angle of release? The easiest way to start off is to choose the one with perhaps the lowest angle of release and the one with the highest angle of release. And then you're to explain why you want those angles of release. So you're to complete that and also go ahead and answer number 5 as well. So sports in which distance is important have a higher or lower angle of release for each of those. Complete that in your books before, pause the video and complete it in your books before you continue with the next movie. Next slide. Right, now we're looking at height of release, and this is how high you can actually, the height the ball or the projectile is released from. So the higher the point of release relative to the ground, the further the object would travel. Say I stood on top of our gym and I threw the ball from there, and you had to stand on the ground beneath the gym or right below me on the ground. I think I could throw further than you because the ball would have longer flight time in the air because it's been released from a higher point. So what gives us this extra height? We can create extra height by having elbow extension and shoulder flexion, causing the arm to be, which takes the arm straight up above us. When you're shooting a basketball, you do that. It makes it possible to release the ball at its highest point, therefore allowing it to travel maximum distance. This means that shots can be made in a game, that a range of shots can be made in a game. For any given speed and angle of release, the greater the height of release, the greater the distance gained due to the fact that the ball has a longer flight time in the air. So on the next page, top of page 79, height of release. Does it mean... Whoops, I think that was my Siri interrupting me. I think she thought I was talking to her. Does this mean that a taller javelin thrower would always throw further than a shorter javelin thrower? And what is it assuming? Well, if they threw with exactly the same amount of force and angle, initial horizontal and initial vertical velocities are the same, yes, they would throw further. So that would be a big advantage for a javelin thrower. Have a think, what other sports would it be an advantage in? Height of release and angle of release are really closely interrelated because looking at a basketball player, the taller he is, he shoots from a lower angle. If you're a shorty, you've got to shoot at a greater angle, and if you're tall, you decrease the angle. So question 2 is, as the height of release increases, the optimal angle of release decreases, gets smaller. And as the height decreases, the optimum angle increases. So if you're short, you've got to shoot you're shooting from a greater angle. Well, we've got tennis here, where you can see them doing a serve, and of course with the tennis serve, you are going to be sending the ball on a downward path. So of course the taller you are, the greater advantage you have at getting the ball over the net. You can shoot at you can send the ball down at a much lower angle if you're taller in tennis. If you're a shorty, you would have to have a slightly greater angle on it. And of course, both lots would be less than 45 degrees. They would be maybe 20 degrees, a downward angle though. So when you're serving in tennis, the aim is to get maximum height of release. That's why you're to extend your arm and the racket. And the racket and the arm is a long lever. And you do this so the ball can travel downward. The higher the ball is hit, the smaller the angle of release, the shorter the distance travelled, and the harder it is for the opposition to return the ball. And that's what we're always trying to do, make it an attacking serve. The last questions we're going to answer are on air resistance. Looking at a tennis ball and a shuttlecock, if they're hit with the same speed and the same angle of release and from the same height, which one would travel further and why? So the tennis ball, it's got a lot more mass, that means it's heavier than the badminton shuttlecock, and it's got less air resistance due to its shape. It's just nice and round, whereas the badminton shuttlecock has a lot more air resistance. So the tennis ball will travel much further there. Air resistance acts on the horizontal component of a projectile's flight path. In other words, it decreases the distance things can travel. In many sporting situations, the effective air resistance is generally very small. However, there's some key facts that affect air resistance, and it's speed an object is travelling. If you increase the speed, it increases the air resistance. It's like if you're in a car and you put your hand out the window, you're going much faster and you can feel the air resistance on your hand. Whereas if you're travelling slowly, you won't notice the air resistance. The surface area, smooth, sleek surfaces, have less air resistance than ones with pieces jutting out. And we're seeing that coming into people's cycling gear that they wear, their helmet, their clothing, and also their swimming suits that people wear. They try to have less air resistance. The surface area, more surface area increases the resistance. And something with more mass, the mass is the weight of the object. Something with more mass has got more resistance than something with less mass. Could you complete that in your books? Have that all done by the end of your lesson today, please. And then we can move on to Newton's laws and levers, which are ones that are new to you people.